Okay, good morning, and we are back here, or we've returned to continue with our amazing 5 by 12 matrix and the application thereof. In previous sessions, we were on calculating delta, which was the determinant of the source matrix for circuit analysis problem, and specifically for three-mesh circuit analysis problem, three-mesh, involving 3x3 matrices and three-mesh. We're going to continue with that, but we're going to use a different model circuit, and we will do the calculation. All right, my name as usual is Dolphy Gilpin, and let's draw a circuit that it will involve let's draw some source voltage here. A simple circuit. I will omit this line. This is not in it. Or let us even say draw 2-volt supply here. We want a V2 in series. And say this is 480 and 480. Say this is now 5 volts, 5 ohms rather, 2 ohms, 1 ohms, 3 ohms. Simple circuit. Whereas the resistance might not be realistic with the circuit. But then we're saying now that delta was equal to the determinant we call this mesh 1. Mesh, we should go clockwise. All right, everything is going clockwise, so we're going so for the I1. And so we call this mesh 2. Mesh 2, and this mesh 3. And this will be I3, I2, and I1. And we'll make it as simple as possible. So we say now that delta in mesh 1, we have now the resistance in the element, remember, is now R11, R12, R13, R21, R22, R23, R31, R32, and R33. And we put in the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. And so we say delta was the determinant of that. All right, that's as far as I go. We're going to just drop in the elements by inspection here. So we say, no, that's equal now to the determinant of mesh 1, R11 will be equal to 3 and 5, 8 ohms, positive 8 ohms. R12 is the resistance is common to mesh 1 and mesh 2, which is 5, and it's minus, but mutual resistance is negative anyhow, and R13 is the resistance common to mesh 1 and 3, which is 3 ohms. So they're positive, but mutual resistance is negative, so takes on that. And R21, resistance common to mesh 2 and 1, 5 ohms. R22 is 5 and 2, 7 ohms. R21, 2 and 1, 5 ohms, negative. And R23, rather, 2223, resistance common to mesh 2 and mesh 3. There's no resistance common to mesh 2 and mesh 3 here. So that's 0. Now R31, resistance common to mesh 3 and mesh 1 is 3 ohms. Should be a plus according to this sign here, but because of the mutuality, mutual resistance take on negative sign. And R32, resistance common to mesh 3 and mesh 2, 3 and 2, is 0 again, and R33 is 3 and 1, 4 ohms. Make it as simple as possible. So delta is equal to the determinant of that, and let's quickly say now that we're going to calculate the determinant, and we're going to find now I1 is equal to n I1 over delta. I2 is equal to n, numerator value, I2 over delta, and I3 is equal to n I3 over delta. And you see now that the voltage value here is now that V1, V total here is equal to V1, shouldn't call this to VA and VB, not to confuse the numbers with the mesh itself. V1 is equal to VA plus VB equal V total, that would be, say, 960 ohms. And V2 common to mesh 2 will be 0, and V3 will be equal to 0. So we don't use the Ohms circuit, Ohms law, and say now that V is equal to Ri, or that now 960, 0 voltage will be equal now to R, 8 minus 5 minus 3 minus 5, 7 and 0 minus 3, 0 and 4. And I1, I2, and I3. I will take a break here, and as we come back, we will calculate the current and the numerator value by replacing the voltage in the corresponding columns. So as we return, we'll continue to calculate delta, the determinant of source matrix, which is this one, and subsequently the current.